the difference between face verification and face recognition? In face verification, we are giving an input image or input name of a person, or sometimes employee ID of that person. And we are checking whether this image or name or ID, they belong to that particular person or not. This is one-to-one verification. Whereas in face recognition, we give an input image and we check with a database of k persons, maybe that k 100 or 500 or 1000 or 10,000. In that database, we are checking whether this particular person belongs to this company or not. In that company, k persons are working. So we are giving an input image and we are checking that identity with the k persons. So this is a 1 to k problem, whereas face verification is an 1-to-1 problem. In face verification, if we are getting 99% accuracy, that is good. But in face recognition, if we are getting the same 99% accuracy, that might not be good. Because here we are only missing one case. Here, if we are taking k is equal to 100, if we get 99% accuracy, then there might be chance for each person it is missing one time. So 100 times it is missing. That's why in the face recognition, we require an accuracy of 99.9%. More than that, we require in order to get a very good face recognition system. For example, here we have given 4 persons. There are 4 persons. In generally, these are the images we are giving as input, maybe to our convolutional neural network. But in real time, the employee picture is captured only once. This is the employee picture captured. But the employee picture, while maybe after 1 month, or maybe this picture was captured with some other light conditions. Some other time when the picture, these two pictures are of same person. So when we give this as an input to that network, this has to recognize and tell, yes, this is our employee. And when we give some other image, this has to tell, no, this is not our employee. So we are asking our model to learn from one example. We are saying we are giving only one example because each employee image is stored one time. If we are having example 1000 employees, 1000 images are stored one time only. So we are giving one example and we are asking to recognize the person again with the different image. This is the different image, but of same person. We are asking our model to recognize it again. Okay, per suppose if we are having 5 persons, we will give an image and we are using a convolutional neural network. In the final softmax layer, it will detect that particular person and mentions, yes, this image belongs to that particular person. But if a new employee is added to our company, 6th person is added to our company, then we have to change the structure of the softmax layer. We have to take 6 outputs. So every time whenever an employee is being recruited, whenever an employee is being terminated, we have to change the structure of the convolutional neural network in the last layer. So this is not a very good approach to go. That's why we are learning a similarity function. What is this similarity function? We are representing it with d, where d is denoting the distance. We are taking an image 1 and we are taking another image 2. We are asking what is the degree of difference between these two images. If the degree of difference is small, that refers these two images belong to same person. If the degree of difference between the images is very high, then it indicates that these two images, they do not belong to same person. We are taking the value, maybe tau, we are giving a threshold value for the verification problem, and we are mentioning if the degree of similarity is less than or equal to tau, yes, that new image which we have given as an input is of the same person. But if the degree of similarity is greater than tau, then that image is of the different person. This is how we will proceed with the face verification problem. In the face recognition problem, we are taking the more than one person here. There are 4 persons. And this time we are checking, we are giving this is the input image. We are checking what is the degree of similarity. Then we are checking with the first person, the degree of similarity is 10. Then second person, the degree of similarity is 0.1. Third person, degree of similarity is 9. Fourth person, the degree of similarity is 5. This is indicating that this image belongs to this particular person because the degree of similarity is very less. In this case, even if a new employee is added, we are just adding that person to our database only. There is no need to change our convolutional neural network structure. So for that reason, we are defining a similarity function, and we will discuss how it will be useful for us in implementation. We are taking an input image, convolutional neural network, and then followed by fully connected layer. If it is a classification problem, at the time image recognition, in the final layer we will have the softmax, and we will tell whether this face or whether this image belong to this particular person or not. We are intentionally removing the last layer because we don't need the last layer. In this fully connected layer, we are having 128 neurons. This is an encoded output of this image. We have removed the last layer and we considered this layer. We are taking another image. We are using the same network with same parameters. And again, we have got some other output. This is also encoded version of this second image. We are representing the first encoded version with the fx1, second encoded version with the fx2. Now we are comparing this fx1 and fx2. We are representing this as fx1 minus fx2, normalized value of that whole square. That is the degree of similarity. So in order to find the degree, we discussed as previously, we are defining a degree of similarity. Why degree of similarity we are defining? Because it is very difficult. It is difficult to change every time the softmax layer, last layer. In order to not to change the neural network structure, whenever a new employee is recruited or existing employee is terminated, we are defining a similarity function. And now with this similarity function, we are finding the difference between the encoded values for the first image and second image. If this difference is small, then we mention x1 and x2 are the same images, belong to the same person. If the degree of similarity is very large, this indicates that these two images, they don't belong to same person. Now we are taking an anchor image. Anchor image means you can take it like a test image. It is an anchor image. And this is a positive. What is this positive indicating? This is the same person, another image. So these two images belong to same person. So the degree of similarity will be very less. And we are taking a negative image. What is this negative? This is indicating that this negative image don't belong to the same person. So the anchor and the positive, if we take the degree of similarity, that will be very less. And anchor and negative, if we take the degree of similarity, that will be very high, which is indicating that that image do not belong to this particular person. Okay, we will write some inequality. Definitely the degree of similarity between anchor and positive is always less than or equal to degree of similarity between anchor and a negative image. There is no doubt in that. We are bringing this expression to the left side. And finally, the inequality relation is FA minus FP, normalized value whole square, Fa minus Fn normalized value whole square is always less than or equal to 0. This is the learning objective we are expecting our convolutional neural network will learn. But there is a problem with this. If we give an image with the 0 vectors, means there is no image at all at that time. Because there is no image at all, it will be considering, even if we at that time it will be 0, means if we give no image, minus Fp, example minus Fn, we are considering at that time also we are this learning objective will be fulfilled. So if we wanted to avoid that, that's why we are taking a margin alpha, a small margin. We are mentioning this margin value may be 0.2. What it is indicating? Example, if we consider the anchor and positive images degree of similarity is 0.5, and we got the anchor and negative degree of similarity is 0.51. At that case, when we are getting 0.51, general scenario is we have to mention that that particular image is a negative image because the degree of similarity between A and N is high. But we are saying that should not be allowed because the alpha is only 0.01 here, where the alpha value should be at least 0.2. So definitely the anchor and negative value degree similarity between the anchor and negative images must be 0.7. This is the margin we are expecting. Okay, how we will implement the loss function for this? We are taking a loss function with 3 values: anchor image and positive image and negative image. This expression we have already discussed, and we are expecting the loss is maximum of this expression comma 0. Per suppose if this value is negative, then that is indicating if it is less than 0, then maximum of less than 0 comma 0, 0. So if this expression is negative, at that time the loss will be 0. If this expression is positive, that value will be given as the loss. This is the loss function just for one training sample we have considered. We are taking the entire training set, then sigma I is equal to 1 to m. This is the summation of all loss due to the input all training samples. That is what we are calling as cost function. So example, we are taking 10K pictures in the training set for the 1K persons. Why we are taking 10 images for each person? Because here we require an anchor. We are taking an anchor image example. We require a positive image, where that positive image must be of the same person only. That's why we are taking another 10 pictures, which we can give as a positive image. Whereas the negative image can be, we can consider any other person. That is there is no problem with that. So that's why we are in the training set, we are taking 10 pictures of each person. We are considering 1,000 persons, and the training set is 10,000 pictures. How to choose these triplets, the anchor, positive and negative? If we choose the anchor and positive and negative images randomly, then this condition is easily satisfied. Example, we are taking an image, anchor image, that is one. The positive image must be some random person. Maybe this is the positive image, anchor, some random person. This is one person, this is second person. And negative image is some other random person. There is a chance that easily this condition can be satisfied because there are many images randomly we are considering. Sometimes in our first pickup only, definitely this condition is satisfied. Then there is no work for the gradient descent, and we have not actually trained our network. So that's why we have to take, or we have to choose those kind of triplets which are very hard to train. If we take the triplets in such a way that the difference between the anchor and positive, anchor and negative, almost they are similar, then our gradient descent will try to minimize the cost function, and it will try to learn that will be useful for us. Example, this is an anchor and this is a positive image and this is a negative image. We have some other anchor and positive and negative image. This is how we have to consider the anchor and positive and negative.